Okay, in this video I'm going to show you how to use the radiance section of the workflow to perform a daylight simulation with dynamic shading. We're going to start by looking here, where we're going to choose the BSDF files that we want to describe our dynamic shading and the window coding. We're going to go to the BSDF section of the shared assumptions here, and I want to use the blinds and low E. So we have both Venetian blinds and a low E coding on the window. You can see here I've already connected them to these two components, where this list index just allows us to choose which number on the list we want to connect to that one. I can just show you with the panel that the window component here, the window group, has the low E BSDF file. Remember, it has to be XML format when we're using radiance. And it's all the same box is connected to the blinds section here, and we've chosen number one, and here you see that it's the blinds BSDF file that is connected. I'm just going to delete that again. And then we connect the blinds XML file to this component, which creates a BSDF material, and this component creates the blind states. And that means that we have dynamic shading when we connect it to this window group up here. The window group is connected to this data point along with the rest of the geometry. Here we have all the different types of surfaces that we're using. Here you specify the material, so you give it a name and you give it a reflectance. The reflectances are done based on the EN 17037 standard, and we've chosen the middle values of the spectrums for each type of surface. The geometry comes from the radiance geometry section of the shared assumption. And then we connect this data point to the run radiance analysis component over here. This component also contains information about the analysis grid, which is created here based on the test geometry that is a BREP imported in the radiance section that was explained in the shared assumptions video. Then we create an analysis grid, and over here we create the analysis recipe. We're doing a 5-phase daylight analysis, and you choose the analysis type as well, so you can get illuminance, radiation, or luminance. We're going to go with the illuminance analysis. Down here you have the radiance parameters. We're not going to go into details with those. Now we're ready to run the radiance analysis. I'm going to double click these two toggles to write and run the simulation. And I'm going to pause the recording while I do that because it may take a while. Alright, now the calculation is done running. Our output is the illuminance values for the room as we specified in the analysis recipe. We're going to use that to calculate the spatial daylight autonomy over here. We're going to start by connecting the blind states. That comes from this component down here. That is calculated through this component, which we created here at MicroShade. It takes the binary shading schedule as input. That's the one we calculated in the shared assumptions video. And it changes the format so that it matches what is necessary in this component. You can see it here. So we make sure that that one is connected to the blind states in the SDA component. And the occupancy schedule is a bit special because we're doing it according to the new EN 17037 standard, which requires that you use the amount of daylight to create your occupancy schedule. And they've defined that as the 50% of hours in the year with the highest levels of diffuse horizontal illuminance. And we're going to do that by taking the diffuse horizontal illuminance from the weather file that we imported in the shared assumptions video. It has to be the design reference year data, and I'm currently using one for Copenhagen. And you use that as input. This one just separates the strings from the numbers, and we only need the numbers as input here. And that allows us to create a daylight hours binary schedule, which we can use for the blinds, for the occupancy schedule, sorry. And we use this Honeybee Plus component to create the occupancy schedule based on the numbers from here. And that gives us a spatial daylight autonomy of 66.6 in this case. You can also calculate the UDI, for example, using this workflow. You can do that in this box up here. This one also needs the blind states connected, so I'm just going to do that. Here we go. And that was a quick run through of how you do a radiance daylight analysis with dynamic shading in the workflow.